So welcome everybody. Welcome to the virtual session DC Nano-Grids. We have our live audience here, both from Bangalore as well as from worldwide. Thank you all for joining us. My name is Hannes. I'm from the research group Microenergy Systems from the University of Technology Berlin. And yeah, I'm very excited about this session. We have participants and speakers ranging from California to well, actually all the way to Singapore, but he's here with us now, Timothy. Before we start, just a couple of advance notices. So this is a live broadcast and video, so please be aware of that. And we also do recording. I hope you all agree with that, just to share what we gain here in knowledge to be able to share with the outside world. And yeah, so for the virtual audience, please keep posting your questions. We will do it in a manner that the four speakers will present for 10 to 15 minutes. We'll do a short Q&A from the audience that is here. And at the end of the session, there will be 20 minutes of discussions where we'll actually come back to the questions that you've been posting us. So keep texting, and we will select the best questions we can find. So thank you very much for that. So then without further notice, I will hand over to Bruce, who will join us from California. He's been awake, I think it's past midnight already, so thanks, Bruce, for bearing with us so late. And without further notice, I'll hand over the word to you. Thank you so much. So, Bruce.
Greetings, everybody. Can you hear me?
Yeah, your webcam as well?
Yes. Let's see. There you go.
Yes.
Great.
So good to have you on board.
Yes. Well, thank you so much for thank you so much for the opportunity to speak with you. As Hannes mentioned, I'm calling from California, where it's seasonably late and unseasonably cold, but never mind. Anyways, I'd like to talk about DC technology and particularly the role that communications can play in providing better DC technology to enable capabilities we don't have today. So I'd really like to cover three particular topics: terminology around grids, to present what I call a network model of power based on local power distribution, and then outline some technologies we need for the coming, really to start from where we want to be in 30 years' time and work backwards towards the present to make sure that we end up where we want to go, instead of starting with what we have today and then making incremental changes that, that may not do that. So there's a lot of words on this slide, and I hope these slides can be distributed later. In terms of the definition of a microgrid, I generally use the definition from the U.S. Department of Energy, which is oriented towards systems which are always grid connected, and so that they take that as a focus. But the key aspect of microgrid is the fact that it can operate independently from a utility grid. And so this definition, other than the fact that it needs to also cover grids that are never connected to a utility grid, I think is suitable. And the core aspect of this is it's the capability to act independently. It does not make a definition about the size of the grid, either in the capacity of the system or in the number of people who might be using it. For the term nano-grid, I came up with a definition about 5 years ago, which to me is based on really the issue of simplicity. It's the smallest unit of power distribution that we could find that we can't further subdivide. So it's a single domain of power, a single voltage, a single frequency that's AC, a consistent reliability, quality, and critically price, so that you have a way to understand how valuable power is at any given time. And in this definition, storage is internal to a nanogrid, and a generation entity is a special type of nanogrid controller. It's not a different type of entity. And then there's the term picogrid, which I came across a few years ago, and seems very apt, which is an individual device with its own battery. So it's really not distributing power, but it's an entity which is which is consuming power itself. So those form, I believe, a nice set of terms which I think can be compatible together. I've run across several other different definitions of nanogrid, but naturally I believe that the mine is the most useful going forward. So other useful terms are local grid, which would be either a microgrid or a nanogrid, or perhaps even a picogrid. But if you just want to talk about grids in general that are not a traditional utility grid, as we have in many places. The term mini-grid, I haven't found a specific definition which somebody else has offered which seems apt, but I think the general usage that I see implies that it's a power distribution wherein there is a central infrastructure and as well as customers who are paying for power, but less than some size, either in terms of number of people served or in number of kilowatts. I think that's consistent with how people use the term mini-grid. And then the real issue here is what's the technology by which we distribute power? And by power distribution, it's everything between the generator and the end-use devices, or what I like to say, it's technology that moves electrons from where they are to where they are wanted. And the key question is does this power distribution technology contain communications about power, or does it? Traditionally, we don't do that very much, except in the cases of USB, which actually is widely used. But that's the key, I think, to going forward to having truly interoperable systems. So in terms of my definition of nanogrid, as I mentioned, it's the smallest unit of power distribution. It's like if you have a material, you can make a material smaller and smaller until you get down to a single molecule. But then if you try to make the molecule smaller, it no longer becomes that. So it's the basic foundational unit by which we can construct networks of power systems. Again, single voltage and single domain of these other characteristics. So a nanogrid would have end-use loads that are connected to it that consume power, and then connections to other nanogrids, very much in the way that IT network equipment has individual computers or other devices attached to a switch or router, and then has ways that the infrastructure connect to each other. And again, in a fully functioning one, all these links would include communications. And this would be the general model. And while today's examples of this approach are small in electrical capacity, with USB originally starting at 2.5 watts, over time we can increase the capacity, the electrical capacity of links, certainly up today where you get 100 watts across a wire, and then eventually up to several kilowatts or even more for higher capacity links. So as an example of how you might deploy this in a real community, you really want to have communities be networks of local grids, where in every single building, regardless of what type it is, you could have one or more nanogrids internal to that building, including some generation. And I really expect that most or even perhaps all nanogrids going forward, nanogrid controllers will include a storage element locally to help balance supply and demand, even if there's larger amounts in some central location within a community network of nanogrids. And you have all buildings there connected into a mesh network of wires so that power can flow optimally between them depending on the relative availability of supply and demand of power. And while this diagram over here shows a very small network, it could be of arbitrary. And the key point about this technology approach is that there would be no central control needed, which is good for privacy and security as well as interoperability, very much in the way that the internet doesn't have central control either. Another feature that, hello?
Yeah, I'm sorry, we can't really see a slide actually. We're still on the first slide.
I'm sorry, I didn't catch that.
You're sharing the wrong screen.
Oh, I am? Oh, did you miss me?
Cool. Thank you. Sorry for that interruption.
Should I, okay. Should I go back and show the other slides or just continue? Okay, I'll just
Cool.
oh.
Yeah, just continue.
Yes, sorry about that. Anyways, so such a network could be highly dynamic, where you can add and subtract equipment within buildings as people acquire them or as equipment breaks. And you can add or subtract the connections between the buildings on an arbitrary basis, and the system would automatically readjust. And in such a model, you could have a connection to a utility grid all of the time, never, or only intermittently, and the fundamental technology internal to the grid would be the same regardless. And the key point in all this is that if you have a network of power like this, the question would always be, how does the system know in what direction power should flow? And the answer is the relative price, because again, each nanogrid is its own local price. Power is only going to always flow uphill. So as an example of technologies that exist today or almost exist that do this, this is one called UPAMD that was developed by IEEE. It's actually very much in the very similar to how USB now operates, wherein power can flow in either direction across a link, where there's communications about how much power to flow, where you can create these networks of end-use devices and hubs and generation of storage to enable these arbitrary networks of power. This technology is being approved as an IEEE standard, although I think now that the new USB power delivery standard is available, it probably won't be successful in the market, and USB will take this up. But this shows a lot of the different examples of how you can connect devices to each other to move power around flexibly. So in terms of where we really want to head in the long run, both on a national scale and within each building, and this is intended to apply both to industrialized countries and really any country. We really want the technology by which we distribute power to be independent of the grid context, in the same way that for communications we use internet protocol technology regardless of our application context, that it's a universally useful technology. And the grid context, whether you're connected to a microgrid or a utility grid or not, should be able to change at any time, and all the technologies should still be just as useful. Most generations should be local. That has a lot of advantages for efficiency and flexibility. And the key thing is to guarantee the reliability of electricity supply locally, not guarantee it centrally as we do with utility grid systems. And we want to have utility grids in general, but they can be smaller and less reliable than they are in industrialized countries today, because the reliability will be guaranteed locally, not centrally. And therefore, they should be a lot less expensive, and on a societal basis, the money you save by having smaller utility grids can be invested within each building and in local communities. So what this means that we need for technologies is universal technologies that are applicable across countries, building types, so that and uses, so that no matter what your built context, you're using the same power distribution technology to attain what I call universal interoperability. Therefore, power distribution can be based on commodity products and therefore be low cost. And so that the term I use for this approach is local power distribution for this network model of power. And while this naturally begins with DC power, we do need and want to accommodate AC as well, because for the foreseeable future we'll have lots of AC power, even as the amount of DC increases, both in the energy access context as well as in developing countries. So that's my presentation, and I apologize for that slide mix-up, and happy to take a few clarifying questions if the timing allows now, or also in the general discussion later.
All right, Bruce, thank you very much.
Thank you. Oh, actually,
Thanks a lot for that input. I hope you can hear us now.
Oh, I can absolutely hear you. I will be in at a conference in Bangalore in July, and so if there's anybody there or in the nearby vicinity who would be good to meet with, please contact me. Just Google my name.
Okay, excellent. I think that's good news to everybody here who is actually from Bangalore. So, because we have the next speaker lined up already, I would like to open the floor for questions from Bangalore to California right now. So, are there any questions? Please raise your hand. Don't be shy. All right. So maybe Bruce, just one more question from my side. You know, in the past days here, we've talked about a lot about that, you know, DC and AC grids, and that, you know, that whole discussion, which has been changing in the past 2 or 3 years. And you presented some of that, what is already out there, and I think the USB standard is quite interesting if you look at it from this combination of data and communication. But when it comes to that, bringing that on scale and really using that for higher transmissions, do you see the USB port really developing in that direction of higher power consumptions, or will that stay in this range of 100 or maybe slightly above that range?
Well, USB itself, I think, will likely stay more at that scale. But I think what we can do is adapt the same communications paradigms to higher capacity links. And as an example, the other place where we have managed power distribution already is with Ethernet, wherein across an Ethernet cable, when you distribute power, there is also communications about the power in parallel to the generalized data communications. And as we develop technologies such as the 380-volt DC standard, where you can get much higher power capacity on a cable, we could simply string an Ethernet cable along each 380-volt cable to provide the communications, and therefore, and use the same semantics of communications as we do with USB, or these very similar ones, to get these higher capacities. So you're never going to plug a 380-volt cable into a USB port, so it's not like we have to have everything have a common connector. But we simply have to have a number of technologies that can scale up to much higher capacities.
Okay, excellent. So is there another question from the audience? Yes, Daniel.
Hi, Bruce. Thanks for your presentation. And yeah, it's a pleasure to have the chance to follow such a presentation this way at this conference, and thank you for making that possible from your side, even though it's obviously night. It's not too easy to see you. Maybe your light is a little bit dark there, or we have a problem with the video. I appreciate your points, and one aspect I see that the USB discussion, for example, is about also we have to discuss this standardized kind of transmission elements for DC connections, and so far we are at a very experimental level, but from my perspective, I guess it would be very important that we are sooner or later starting to discuss standards for exactly those kind of possibilities we have in our target countries, and I guess the USB standard comes out of something where basically all the infrastructure has been already developed. So what is your opinion on that? And yeah, I guess what do you see as an outlook for standardizations in this process?
Well, with USB, the products which use the new USB standard, which is called power delivery, sort of USB-PD, with a new USB cable, which is actually a different connector. There's very little of that that's now available. It's coming onto the market only now. So in fact, it will be some number of years before we see really wide usage of that. But once we do, and once people experience the flexibility and the capabilities you can get with this approach, then I think the example of that will spur the development of higher capacity technologies. In the same way that Ethernet started out at less than 10,000. Well, since Ethernet was introduced, its capacity for communications has gone up by more than a factor of 10,000, or actually really 100,000 in terms of how many bits per second. So it's the experience of using the technology which will drive the development, the availability of products and better and more technologies of higher capacities.
All right. Thank you very much, Bruce. I'm sure that there's more questions, but we'll keep them for the big discussion round towards the end of the session. So now, after having looked at what technology can really do, like where are we heading in terms of combining power and communication, I would now like to hand over to Fabio, who will join us from East Africa. And actually, Fabio, I'm not sure if you are in Nairobi or Dar es Salaam right now, but yeah, I'm looking forward to your presentation of an example where DC nanogrids are already in place right now. So Fabio, yeah, glad to have you on board.
Hi there, hi everybody. I can, yeah, I'm in Dar es Salaam actually, so, and this is where our operations are based. I don't know if you want to send me, yeah, I can see this show my screen, and if you can just confirm that you can see my presentation now full screen.
Yeah, yeah, you got it.
Okay.
Join us without webcam, but we can see your slides. Thank you so much.
Yeah, unfortunately, I don't think my connection can support a webcam, so we'll go with the slides. I'd like to, first of all, thank you for hosting me at this event. I'm very happy to be able to participate. It was very interesting to listen to Bruce's presentation and perspective. I think we share a lot of ideas and philosophies, and also our view on the market on DC grids is very similar. I am the Chief Energizing Officer for of Devergy, which is a company that provides rural energy services in Tanzania, and I will, in my presentation, I will just go through a bit of what we do and why we do it, how we do it. So first and foremost, we have started the company in 2010 with the idea of providing freedom of choice. So what we really were after was reducing the divide that there is between population in rural settings and population in cities, especially in developing countries. So the idea was to be able to just not have that divide anymore and have people be able to use appliances and be able to use electricity in particular in rural villages which are not connected to the power grid. So we're not looking at interconnection to the grid. We are doing totally off-grid, so-called greenfield DC solar smart microgrids. The offering really is 24/7 energy access, which is entirely based on solar photovoltaic technology. And when we say we provide energy services, that's because we provide a bit more than electricity. In fact, we embed in our offering also the appliances to use the electricity. Now, this is fundamental because both because of the fact we're using DC technology, and so this makes it a bit harder to access the appliances, but also just because of the lack of disposable income, it's very hard for our customers to access appliances. And so we find that the only real way to have an impact, to make a change, is to provide also those and not just the electricity. As of basically the appliances we can provide in our DC grids are the ones you can see in the picture. So we really go from a simple lighting and phone charging, which is always a starting point for a new connection, but then we can go up to TVs and fans and beamers, sewing machine, refrigerators, stereos, and so forth. So it's quite diverse, and we see relatively little limitation compared to what the needs and desires of our customers are. From a customer perspective, it's a relatively simple proposition. The customers pay a $20 connection fee, and this connection fee is mostly there to sort of provide a filter, and also make sure that the customers have some sort of skin in the game and they're not just getting connection, you know, because you never know. They actually, we want our customers to want our services and to you know, attach a value to that. After the connection fee, which is a once-off fee, they receive an energy meter at their home, and they have then the ability to start buying energy services, and we sell that in energy packages which are sold per day, per week, or per month, starting with 20 cents of a dollar per day. All payments are done via mobile payments, so this means in Tanzania using systems like Vodacom M-Pesa or Millicom's Tigo Pesa. These are systems that sort of provide you with a mobile bank account, so a bank account effectively that is attached to your SIM card, to the phone line. So we never handle cash, but the customers directly buy, and automatically whenever they buy a new energy package, then within normally 1 minute or two, they have the package delivered to their meter automatically. All customers start with lighting and phone charging. We provide them with 2 lights and a phone charger as part of the connection. But then they can grow to more, and normally they can do that either by buying directly appliances or by having them on a lease-to-own basis. So they pay in a few installments a rental fee, sort of, and then after 3 to 6 months, depending on how important the appliance is, they become the owners of that appliance. So the process we use is sort of innovative, and for us it's very important to have a process that allows us to reduce the cost of the capital needed to install a new grid. So we can do this by first installing very little power per customer. So we have very low initial investment. The little power per customer comes from the fact that we only install something like 5 watts per customer on average in a village. Now, but thanks to the fact that this is a DC microgrid and not just simple solar home systems, it means that effectively the customers can pull out of their meters a bit more energy than what we have installed on average. So just working on the fact that you know, some customers will use less and some customers will use more. Even if we have installed only 5 watts per customer in equivalent, you know, watt peak capacity, and the battery attached to that, of course. The reality is that the customers can pull up to 250 watts, and then we actually maintain on the company side the task and the duty to increase the capacity of the grid as we see fit. So the third thing we do is we actually measure the demand thanks to remote monitoring and control of our grids. So we can talk at all times, and we receive data continuously from our grids, both from the say generation points, so the solar panels and the batteries, but also from the meters, so the load side. And thanks to that, we can really see at all times when you know, the demand, so the energy usage in a grid, is increasing to a point that is hitting the capacity available. At that point, very quickly, we can install more capacity. And when I say very quickly, I mean that the installation of a new power generation module takes about 30 minutes. And in reality, we normally have a reaction and response time of about 24 hours because we keep these modules on site and we use local technicians from the villages to install them. This is in reality what the system looks like. We have what we call an M-box, that is an energy box. And this is this tripod you can see to the right. These are effectively solar home systems, self-standing, so that we do not have to care about how, you know, having to handle the different roofs and different installation houses and so on. We just put in the middle of the street. Of course, we have an agreement with the villages, and they effectively provide energy to the grid. I hope you can see that on the remote connection, but there are a couple of orange cables, but you can probably see them better in this second pitch. And so this, we install one of these M-boxes, so these power generation points, every about 10 houses at the beginning. And then you can see in the background on the house an energy meter, which is like this one in this new picture. And these energy meters really are what allows us to see how much energy is being consumed, and of course also to disconnect the customer in case they have fully used the energy package. I should probably mention that every energy package that customers buy are prepaid, and so the customer will buy, I don't know, a week worth of electricity, and then after a week either they have already bought a new one or it will automatically disconnect. then we collect all this data coming from the meters and the generation points. And I hope you can see this picture properly. But the green dots, so the green circles, those are the energy meters in a village. This is a screenshot from our backend management system. While the white squares, those are generation points. So the solar panels and batteries. Now we can click on any of these and look at information which is real time regarding the technical status of the grid, but also information about the customers, the revenues from that particular connection, and any customer relationship or issues we may have had. As of today, we have connected 850 customers in 6 villages, and we're providing 250 watts per connection to every connection point. Of course, it doesn't mean that everybody uses that. In fact, most of our customers use, on average, less than 10 watts. But if some customers have a TV, maybe a fridge, and then so they use higher amounts of power, so maybe 10, 20, 30, up to 50 watts realistically. So the 250 watts per connection is really something that it's quite enough for us for what we see as a service. We've been doing this in the field for about 3 years, and in the villages where we're present, there is a penetration of about 75% or higher, which means that we have connected in those villages more than 75% of the households in the village. And on average, we see a saving on energy bill of about 30%. This is compared to buying kerosene and phone charging expenses before our arrival. We're now working on 8,000 new connections in the coming 2 years. That's about 50 villages. And we are then intend to continue later to 90,000 connections in the next 6 years. Ideally, of course, even more, but we think this is a realistic forecast for the future. The other thing we really are shifting a bit is focusing more and more on productive users, so really focusing on business customers and providing them the possibility of having revenue-generating activities. This is something where we see there is a lot of demand, and we see that as a very interesting strategic market for us to tackle a bit better. This was it, and I hope if you have any questions, I'm very happy to answer. But before we go into that, I'd like to actually mention one thing on the USB discussion that was earlier. We're looking at that with great attention. Already today, we try to use as much as we can appliances which use USB, but we really hope USB will become even more of a standard. As far as we understand, USB will be able to provide up to 5 amp, which at 20 volts will be 100 watts, and that would be by far more than enough to power basically any of the appliances that we currently provide to our customers. So I think there is a lot of potential there. But as Bruce said, it's going to take a bit of time, and it's going to take people really get excited about that, and then manufacturers follow that hype and interest. Again, thank you very much for your attention, and I will be very happy to answer any questions if there are any.
Thank you very much for that very interesting presentation. So, are there questions from the audience here in Bangalore? Asma.
Are all the houses connected by wires?
Yes, every single house is connected to our grid. So we really make a grid of these M boxes, these tripods you saw in the slide earlier, and so we run wires, we run cables from one of these tripods to the next one, and these cables go through the houses in between, and then along these cables we install these energy meters. This is for the electrical part. For what concerns the data and so the communication, we actually use a radio protocol to communicate. So data does not run on the cables. There are many technical solutions, many technical reasons for that, and we elected to go this way. So an independent radio-based communication protocol in the communication network in the villages.
Further questions?
Hello, Fabio. Thanks for your presentation. My name is Daniel. And I appreciate what you're doing there, and I guess it's a kind of first mover activity you're doing there, and it's amazing to see that these kind of things are evolving. And my question to you related to what we are doing here at the conference is, what is maybe what we should push more to step forward with these kind of activities you are doing there? Because I guess this is part of a future approach for all our people living under such conditions, and I would really like to know where you see the main constraints that could be addressed, and where actually a whole community that I see us being part of could push this.
That's a very good question. The answer is definitely not that simple. There are a few items that we see as very, very important for increasing the impact and the popularity of these approaches. One is definitely that there must be a favorable regulatory environment. We are very lucky in Tanzania. We can do this, and because of the very small size in terms of power of our grids, we are mostly deregulated, or technically speaking, we have a very light-handed regulation. So there is a regulation which basically says, don't worry, just do it. You don't need a license, you don't need to register your tariff, you don't need to comply to a national tariff. This is a fundamental point. We have seen other companies and other players trying to do similar things, maybe with different technology, maybe different approaches, and the regulatory issues might really stop something like this. And I should also mention the real side effect of having a either non-favorable or even just uncertain, so not unclear regulatory environment means that investments cannot really flow in, because investors will perceive too much of a risk and will not be ready to invest in any entity doing these things. So that's one aspect. But I think I touched quickly on the appliances, and I think it's important to insist on that. It's very, very important to start having standardization around the appliances, standardizing around maybe standardized connectors. That would be already simple. Like today, we are having this conversation with other energy access companies to try to just say, okay, if you're using 12 volt, this is a connector we're all going to use. If you're using 24 volt, this is another connector we're all going to use. But we need to have more appliances. We need to have more attention to the whole load side. It makes very little sense to have to use AC or inverters. We can actually do pretty much everything without an inverter in between. And I think fridges are not enough of an example. I think also grain mills and rice huskers. These are typically things where people thought, oh, we can only do that AC. But the reality is that they can be done DC very nicely. But we need to create a market. We need to create enough momentum so that manufacturers start saying, hey, there is a market. Let's do these products. Let's make them and sell them at a good price. So I think a lot of if the community was to get together and start being sort of all together with the suppliers, saying, hey, we need more of this stuff. It's we don't want just to see the AC version of this. And very often, actually, the things we're using as AC are already DC, but they have an adapter inside to go from AC to DC behind the scenes. So that's something I think that will really change the sector as well. Yeah.
Excellent. Thank you, Fabio, for the extensive answer, and I think that also addressed one of the questions that we heard from the virtual audience, which wasn't mentioned here yet. That question, if we're going to have appliances very soon that can be AC and DC, and I think we might be able to touch upon that question later in the discussion now. So, Fabio, thank you once again for joining us here with your presentation. We will now move from East Africa to Bangalore. To Bangladesh, sorry, or to Bangalore as well for the presentation, because Timothy is actually here, who will present a DC nano-grid approach for Bangladesh. So, Timothy.
Thank you very much, and thanks again for inviting us.
Okay, good afternoon, everyone. Glad to be here in this very exciting, interesting session. Live here in Bangalore and virtually over the internet. So I'm going to talk about our experience with solar DC nano-grids in Bangladesh. And if I could get the slides up, that would be nice. Wonderful. Yes, here we are. Okay, so I work at the Solar Energy Research Institute of Singapore, or CERES, in Singapore, and together with my colleagues and collaborators on this project, we're presenting our experiences practically in the field in Bangladesh so far. So the other two speakers, I think, have fairly thoroughly covered what is the concept of a DC solar nanogrid. We take a slightly simpler approach than the previous one you saw with a single generation point in the center and a single battery storage connected to a cluster of houses in a village, like so. Before I go further, let me introduce the project team. So we have a pilot project in Bangladesh, sponsored and funded by GIZ. CERES, representing CERES are myself and Peter Adelman, doing project management and technical development. We're partnering with SolShare, a part of Microenergy International in Bangladesh with Sebastian and Hannes here. And also we're working with Sharia, who will be speaking next, from United International University in Dhaka, doing on-ground support for us there. So in terms of site selection for this project, we had some criteria that were requested by the funder, that it not be too far from Dhaka, so that that we can bring people there to see it. However, we also wanted to go to a village that had already a very low penetration of solar home systems, so that we wouldn't be trying to compete against the solar home systems when we install our nano-grid. So these two criteria are difficult to find in Bangladesh, close to Dhaka. So Sharia and his team, along with the microenergy guys, investigated several different locations around Bangladesh. I'm not sure how well you can see it on the map here, all within a few hours driving distance of Dhaka. And we found this one site. It's a government housing project which seemed ideal. So this is on an island in Minigrids district. It's a few hours drive west of Dhaka. And you can see here in the satellite picture there's a row of huts that are all brand new. It's been built by the government to provide housing for people whose homes and land were washed away by the river. So in total there are 24 huts there. There are 5 apartments per hut, which makes 120 families. And so this is a nice size to do administration of this technology. Here's a closer up photo of the housing development. Yeah, this was taken the first time I visited there, and the families had not yet been assigned to the homes, and so there weren't actually people living in it yet, but there are people living there now. This shows you just another picture of the type of housing that we're looking at here. So let me touch a bit on the technical aspects that we are implementing here for our solar DC nanogrids. We designed the technology for the basic needs of the people. So we're looking at tier 1 and tier 2 electrification, which Sebastian discussed this morning. And so we choose the most highly efficient loads we can. LED lights with 120 lumens per watt, so 1 watt and 2 watt LED lamps of that kind of efficiency. The distribution we do at 12 volts. We are planning to go to 48 volts later to enable us to go to larger distances. But as I'll show on the next slide, even with 12 volts, due to the low power consumption that these loads are using, we can achieve acceptable losses on the cables. So we also have a bit of smartness to our grid. We have a central monitoring system which monitors the status of the battery and the PV and communicates that status to the individual energy meters in the homes. And we do this communication in a very simplistic way using a 3-core cable rather than a 2-core cable for the distribution. And on the third wire of the cable, we put a voltage signal which then indicates to the energy meters what the status of the battery and PV are. So this communication allows us to provide variable tariffs for the end users based on whether it's nighttime and the PV is not generating, or if it's daytime and the battery is full already, then any energy the PV would be producing would otherwise go to waste. So we might as well let the users have it cheaply. And so this way we can encourage them to shift their usage patterns to more daytime usage, for example, for charging their phones, etc. So productive use could also be included in such a mini-grid, but we're not doing this as yet. Okay, this is just an example of the various packages of loads that we're offering. Tier 1, a couple of 1-watt lamps, a USB charger, and a radio. It adds up to around 5 watts. And given these usage times per day, we get less than 20 watt-hours per day. So this way we're able to provide these basic energy services for very little energy consumption. The tier 2, I won't go into the details there. Oh yeah, I promised you to show you the relative power losses that we get on the cables given a tier 1 household consuming 5 watts. If we use a 2.5 square millimeter cable, we can even go to a distance of 100 meters and only get 10% losses on the cables at 12 volts. If we step that up to 48 volts, which we plan to do, then we can go to more than 1,000 meters and still only have 10% losses on the cables. So in terms of the business aspects, our philosophy is to sell the energy service, not the kilowatt hour. I think we've been hearing this message again and again over the past few days, and I truly believe it's a very important concept. Also, we try to achieve buy-in of the local users by having them literally buy in to partially own the infrastructure. So we look for a local entrepreneur in the village who can buy in at least a 20% equity stake in the hardware, and then he will own and operate the he will operate the grid and collect the fees locally, door to door. We don't have any electronic or remote payment system, just to try and make it as simple as possible at this stage. So, yeah, in terms of costs, we can achieve payback in a period of 2 years at kerosene kind of prices of what people are currently paying for kerosene. So then here's a breakdown of the costs of the individual components. The PV module you see is only 7% of the cost of the system. The battery is quite significant. The cabling in this case is quite significant in terms of the hardware costs. The power meters also form a significant portion, and then other small bits and pieces here and there. So I wanted today to talk to you about our experiences installing this mini grid in Bangladesh and showing it in operation. but it turns out that there were some delays with our program. It was meant to be installed last month already. So instead of showing you that, I'd like to talk to you about the issues that we encountered, and maybe try and draw some lessons from that as well. What happened there? So we visited this location several times, and we met with the local member of the government there, and he was very supportive of us, and saying, yes, please go ahead. It's a great idea. In fact, the local member wanted to be wanted to operate the mini-grid himself. It turns out that he's not allowed to do that. He's not allowed to collect money from his constituents. Fair enough. Okay. So we had a meeting with the community leaders to try to find others who would be interested to operate the mini-grid. And this meeting went very well. People asked a lot of questions. They wanted to understand what it's all about, this and that. And we went away from that meeting thinking, okay, great, let's go ahead. Then soon after that, we heard that there was some issue, and so we had to have a meeting with the next politician level up, Mr. UNO. Apparently someone had complained. They weren't happy with what we were proposing to do for some reason. And so, we went to all the way up to the Secretary of the Power Ministry, and he was very supportive and said, okay, of course, yeah, go ahead, you're doing a good thing, this is great. He wrote a letter for us to go to the district commissioner, and so, rather than installing, last time I was there, we spent a lot of time in meetings with various officials, drinking cups of tea, which was equally nice and informative. So, what can we learn from this? I'd like to summarize this experience by saying that I think that there are three aspects that are extremely important to take care of when trying to achieve a project like this. And they are the technical aspects, and I think that we have a very strong technical approach here. I don't see any issue with that. The business and financial aspects, I think also we have that well covered. The cost structure is there to make it work. The local ownership, the local collection of fees, I like those aspects. I think they're fine. But then, the social and political aspects are equally important, and sometimes can be very surprising. Yeah, they caught us off guard a little bit here in this project. So with that, I'll finish, and thank you.
Thank you, Timothy. I would like to ask you to stand behind that thing so we can make use of another microphone. So, other questions to Timothy? Maybe quickly introduce yourself.
Hi, Timothy. I'm very much interested. So what is the issue that caused the social problem to go through the
It's not entirely clear to me. Perhaps there's some different groups within the community, and there might be some jealousy about who was chosen to operate the thing. I'm not really sure. Maybe Sharia can comment further. I don't know if he wants to.
Okay, there's another question. Setu.
Hi, I'm Setu Pels from RVE Sol, a small startup doing similar things to you. And we also have a community-based model in Kenya, and we experienced long-term difficulties with that. So not just startup, but also during operation, that eventually caused us to rethink whether we were actually going to go down that route ever again. So I was wondering whether you had a long-term plan for how that would work, operations and maintenance-wise, and revenue collection over the 5 years I expect the project should last. Is there a structure in place?
Well, not as yet. I mean, I think we need to take it step by step and see how it evolves and develops. And if we find that it doesn't work, then perhaps a pay-as-you-go scheme might be more appropriate. But if we can avoid that and get the local buy-in by having the local share of ownership, we would like to go that way. But I think probably it depends, on the culture that you're trying to work in. Yeah.
Hi, thanks for the presentation. My name is Mitawachan. I'm part of a startup company called Fluxion Engineering Technology. Thanks for the cost breakdown which you showed, wherein you allotted monitoring and panels and different stuff. So I was wondering, what did you include in monitoring? I mean, when you said monitoring, what all it includes basically?
The monitoring there refers to the the central system status monitoring unit that monitors the battery and PV conditions, and it also has some data logging in it as well.
Right, Timothy, thank you very much for that input. We'll speak about that later in the discussion round. And so now we come to our last input, also from Bangladesh. Sharia, I'm very happy to have you here. So you're going to give a little bit of an overview. You know, Bruce was looking at the technology, what could happen. We've seen two examples of how you can implement it in like right now. But I think your presentation heads more in the direction of where in general can we see DC nanogrids happening. So I'm very pleased to have you here. Thank you so much.
Thank you.
Have the slide changer?
Okay. Thank you very much, Hannes. Good afternoon, ladies and gentlemen. So I'm Shahriar Ahmed Choudhury, from the land of world's most successful solar-based rural electrification program. So today I'd like to, tell something about the, different topologies, possible topologies of nano-grids or isolated DC grids. So this is the genesis of my presentation. So before going to details into my topics, so
hold it. Okay, thank you.
I hope you have interest on that. Then opportunities of solar PV based mini grids in Bangladesh, and then DC-AC. There is a debate or relative comparison. I will highlight some of the points. So why we are interested to go for DC. And then possible topologies of different isolated DC grids, then relative advantages, disadvantages of different topologies, and then I'll conclude my presentation and some future outlooks. So, the solar home system-based rural electrification program of Bangladesh is the most successful one. So we have 60 million off-grid people, that is 40% of our total population. And the solar home system-based rural electrification program is run by an organization called ITCOL. ITCOL is a non-bank financial institution that is developed by the Ministry of Finance. So ITCOL organizes funds and also regulate the program. So ITCOL also set the standards for the solar home system equipments, and so far we have installed 3.6 million solar home systems. In total, it's close to 150 megawatt peak. Then 25% of the off-grid people are getting benefit from the solar home system program of Bangladesh, and this program has created a direct job of 70,000 people, direct and indirect jobs, and in total. ITCOL has invested $550 million US in the home system-based program. So the target is to install 6 million solar home system by 2016, and around 27 million people will get benefit from this program, and which is almost 18% of our total population. Okay. So the other of this solution we are having in Bangladesh is we are installing a 4.2 megawatt peak off-grid system for electrification of an island in the southern part of Bangladesh. That is called Hatia. That is a 2.2 megawatt peak solar plus 2 megawatt peak diesel and 5 megawatt hour of lithium-ion battery. It's a huge project and perhaps one of the largest off-grid solution, solar-based off-grid solution in the world. Then we are in the process of developing 10 solar diesel hybrid AC mini grids 4 are already in operation and 6 are under implementation. These are ranges from 100 kilowatt peak to 247 kilowatt peak, and mostly this will be installed. This will be installed in the islands of different rivers of Bangladesh. And then these are all AC minigrids, and we are having around 50 solar DC nano-grids. I mean, it starts from 100 watt peak to 10 kilowatt peak, and then we have a wind battery based grid system for another island of Bay of Bengal, 1 megawatt peak, and that is also a government project. And we have some biomass gasification and biogas based electricity. In total, the capacity is 6 megawatt peak. These are all the off-grid solutions for Bangladesh. So why there is opportunity for PV based mini-grids? You know, so initially when the people of Bangladesh, they get the solar home systems, before that they didn't know what is electricity and what is a better lighting. So the solar home system, they provide the basic needs for them. Say for example 3 or 4 very high efficient and low power, you know, lights, and maybe opportunity of mobile charging, and sometimes the people who are well off, they could take the DC, black and white DC TVs. But after, you know, passing some times, when they are habituated with that culture, then their appetite has increased, and now they are asking, or also they are aspiring to get, you know, entertainment and also some luxury, the communication and others. So people now, they are not satisfied with the solar home systems, rather they are asking for grid quality electricity, whether that is possible. And we had several surveys, and we found that now there is a very good opportunity for installing mini-grids, because we cannot extend grid electricity to that rural areas. I mean, those are isolated islands, okay, and sometimes they are very far from the grid area. Okay, and after some of the surveys, in fact, I'm extensively involved in the mini-grid projects in Bangladesh, and this is our survey results, that people, they are also asking for productive use. I mean, if we can give them the opportunity, they wish to have the small industry. Say for example, there is a huge demand of irrigation pumps, and irrigation demand in Bangladesh is highest when our solar insolation is also highest. That means during the summer season, we can have excess power in our mini-grids, and we can use those excess power into the irrigation to run the irrigation pumps. And we have seen that if we can install a 150 kilowatt peak solar PV-based mini-grid, and with that 150 kilowatt peak, and from the excess power in summer season, we can easily run 10 to 12 irrigation pumps of 2 kilowatt, 2 kilowatt power range. Because, you know, Bangladesh is a riverine country, and our groundwater level is not that deep. I mean, it is within 15 to 20 meters, and very often we can get the water by using the shallow pump. We don't need to use the submersible pumps. Okay. And then some cotton industry, there is a huge demand of electric driven shewing machine, waving machine, or looming machine. Then in the rural village markets, we have demand of husking mills. Then there are a lot of sawmills, and also we have found that some of the people, they are running the lathe machine and welding machine by the diesel based generator, and those can be also the loads of our potential mini-grids. And then there are grinding machine to grind the spices, then photocopier machines, then computer training centers. We have found computer training centers in the rural areas as well, then poultry farms. Then some of the areas, some of the southern part of Bangladesh, we found that there is a huge demand of ice making industry, because, you know, Bangladesh is a riverine country, and there are a lot of people in the village area, they are fishermen, and they want to, you know, store their fishes, okay, so that they can sell it later on in the market, and they can get much higher prices. And also found that there is a demand of cold storage, and of course there are offices, schools, and madrasas. This cannot be, you know, supported by the normal solar home system. So there is a huge potential of mini-grids in Bangladesh. Why DC? So it's a long debate, you know. So I have come up with some of the points that in case of solar DC isolated grids, why we go for DC. Solar PV is generates DC power. Then this power is stored in DC form. We need some intermediate storage medium like battery, because we do not get solar power at night time, so we need to store it. And the solar power is stored in DC form, and therefore if we go for DC grid, so we don't need the inverter for the conversion of DC to AC. And then all the modern appliances such as LED light, televisions, mobile phones, laptop, etc. that are run on AC are also fully functional DC in the same voltage range. Okay. Then battery DC voltage is 12 volt, so we cannot transmit this power in a longer distance, what Timothy has already shown. So we need to, we can transfer this DC power. Maybe we can use a DC-DC converter to step it up, and but 120 volts or 220 volts, DC can be easily transferred in few hundred meters to maybe 1 to 2 kilometers. Okay, adding up or scaling up of DC systems, or adding up DC energy sources in parallel is much easier than AC. As you know that paralleling AC sources, we need the synchronization of the different sources, power generation sources. So there is no terms like power factor in DC systems. Also, there is no inductive or capacitive losses into the transmission lines. Management of harmonics distortion is a concern for our AC grids, AC isolated grids. So if we go for DC, so we don't need to think about the harmonics. Okay, and DC motors are much more efficient than conventional AC motors. That means nowadays we have BLDC motors versus DC motors. The efficiency is very close to 85 to 90%, whereas the common induction motor, their efficiency is 70%. Okay, DC power transmission is more efficient, less expensive than AC power transmission. Simple two-wire distribution network we can develop, and we can transfer the power, and we can also develop the floating system for in case of DC. So we don't need to ground the neutral. So there is a less shocking hazard in case of DC than AC. Okay, so there can be 5 different topologies for DC grids: centralized generation and centralized storage, then centralized generation and distributed storage, distributed generation and centralized storage, distributed generation and distributed storage, and the hybrid systems. So I will explain what these systems are. So this is the centralized generation and centralized storage. This is a common and known to everybody that the power generation of PV panel will be in a central place. Also the storage system or battery will be in a central place. So these systems can be monitored easily, controlled and monitored easily, because all the equipments are in a central position. But there are disadvantages that large area needs to install the PV panels, and for the storage systems we need to occupy large area. In case of Bangladesh, Bangladesh is a very densely populated country and land is very costly. So almost 10 to 12% of the project cost is the land cost. So if we go for centralized system and centralized storage, then we need to invest a lot for the purchasing of land and the land development. So, and the application, this is a common system nowadays. So in Bangladesh, there is a company called SolarEdge. They are implementing this type of systems, and they have already installed something like 25 solar DC nano-grids in the rural areas of Bangladesh. So this is the second option: centralized generation and distributed storage. That means we will have the generation system in a central area, but we will distribute the storage system in the individual household. So what is the advantage? The consumer can choose the storage capacity according to their need. That means if some consumer they need higher energy, then they can buy, or they can take a higher capacity of battery. The grid operator may not need to invest for the storage systems. From our calculation, we have found that the storage systems is almost for the initial capital cost. If you consider the initial capital cost, 20% is almost for the storage of the battery system. And if you consider the whole life, I mean we consider 20 years of a life of a mini grid, and then we found that the battery battery cost is more than 50%. Okay, so if we push this battery into the individual consumer's household, then we can reduce the project cost. At the same time, we can reduce the risk for the investor. So storage battery and controller can be sold to the customers through microcredit, then lower risk of investment for the investor. And application, Schneider has developed these systems, and they have introduced and installed some systems in India as well as in Bangladesh and in Myanmar. Okay, distributed generation and centralized storage. So in some areas of Bangladesh, some rural market, we found that we can hardly get any area to install the solar panels. So, but we can have very good south-facing rooftop in the market areas. So easily we can rent or we can install. Then these systems, can be technically to the central storage system. Distributed generation and distributed storage. This is the topology. I mean, where we'll have the generation, distributed generation, and also we have the storage system in suitable areas, maybe on the consumer's premises, or we can have a small centralized generation and also centralized storage. It depends on the area. Okay, so okay, in this case, we can easily integrate the solar home systems, individual solar home systems into the grid area. If we install this type of distributed generation, distributed storage system, then we can easily integrate the existing solar home systems into our grid network. Okay, and also the individual solar systems, they can sell their additional power to the grid. I mean, SolShare has developed similar systems, and we are hoping to install this type of grid in Bangladesh in coming months. So the hybrid systems, this can be a combination of the all. Okay, it's like our national grid network, where we have distributed generation and also centralized very big generation plant. And in case of national grid, we don't have the storage system, but in case of isolated grid, we can have the central storage system, as well as the distributed storage system. I mean, it depends on the locality, the geographical condition, and others. So the conclusion and outlook. So every topology we have seen that discussed here are some advantages and also some limitations. And solar DC small grids can be a cost-effective solution of off-grid area electrification in the developing world. And we have found that in case of our AC mini-grids, the solar electronics, especially the inverters and others, that cost almost 18 to 20% of the total project cost. So the solar electronics for AC things is 20%, battery initial cost is 20%. These two on a battery and inverters, they cost around 40% of the total initial investment cost. We can, if we go for AC, then we can reduce the initial investment cost, maybe around 12 to 15% lower. Off-grid areas do not have access to grid electricity. There is some, in a debate a few days ago, we faced this question that our ecosystem, especially for electrical appliances, are AC ecosystems. So if we want to introduce the DC systems, then you need to change the ecosystem. But in case of the rural off-grid area, so there is no ecosystem. They don't know what is DC or AC. So in the green field, we can easily introduce the DC systems or local solution. Cost of energy, energy use can be much lower in case of isolated DC grid than with AC. The choice of topology depends upon the demand, the energy use pattern, the local microclimate, and availability of the land, etc. Okay, the battery is a very important part for a microgrid or for an isolator system. Okay, so the size of the battery depends on the demand at night and insolation level at the area under consideration. So the sunshine is steady. If the sunshine is steady as reliable, there is no need for store power for more than one night. Okay. On the other hand, unreliable solar insolation compels the mini-grid designer to have significantly higher capacity of battery. That's why if we can have some productive load which we can use during the daytime, then we can reduce the cost of energy.
Okay, Sharia, thank you very much. I think that was your last slide, right? Okay. So thank you very much. So are there direct questions to Sharia? Sharia, would you mind standing behind the other microphone, then we can use this for questions? So up front.
First of all, thanks Sharia for the presentation. I mean, I have a general question related to market penetration of DC devices. So you showed the list of devices or the equipments demanded by the customers in Bangladesh. For example, you had a list right in one of the slides. So my question is, how many of those equipments or the devices are already available in DC AC mode? That is the first one. And as I add on to this, you said, I mean, the television and the irrigation systems are DC television and irrigation systems are available as well. So how accessible these kind of devices or machines to the people, common people in Bangladesh, for example, in your case?
So for example, the irrigation system is newer, DC irrigation system is newer, but you know Bangladesh has developed a very well off-grid market. So you can find the DC appliances in 12-volt DC appliances in the rural grocery shops. So even you can buy the charge controller, also the solar panels. So these are available.
Thank you. Very good presentation. Very nice. Now, my name is Henry from Kenya. I want to ask about the distributed storage, where you say that the customer can own the batteries and determine how much energy they want to store and to use. But I was just wondering, in such a case, and the systems are interconnected, you have the risk of power flowing from one customer to the other. How do we prevent that?
It's a control system we are developing. Okay, so I think Harness Microenergy is developing the equipment, and we have already developed the equipment for the controlling of power and power flow.
Are there more direct questions to Sharia at the moment? Okay, then I would like both Timothy and Sharia to join us on the stage. We have Bruce online. Unfortunately, Fabio is not with us anymore because we were starting a bit late and he had another meeting. So, but yeah, Bruce, you're still also on audio, right?
I'm here.
Okay, excellent. So we have a couple of questions, both from the virtual audience as well as from here. And we will open the floor just now, but just maybe to start with one, maybe more on the techie side questions. So we've spoken about a lot of models, both from what could be done in terms of topology, in terms of technology, and what kind of business models are out there. But you know, we've had this discussion in the past days about standardization. Do you right now see that would actually help to push DC nanogrids to develop, or quite the opposite, would it hinder that innovation? And Bruce, just jump in when you want to add something from your side.
You know, I think standardization is extremely important to help industries.
Be quite firm. Okay, and further away.
Firm and further away. All right. No, I think standardization is very important. But it needs to come at the right time also. And you know, just looking at all the different topologies that we have here and all the different things that we've been discussing and describing, different voltage levels that we're looking at in the DC scene. I think that if we were to bring in standards and say, hey, if you want to build a DC nanogrid, it has to be this way, then that will just stifle innovation at this stage. Yeah, I mean, we need to explore this whole field for a while first, maybe a couple of years, see what works, see what doesn't work, find the best practices, and then standardize.
Okay.
Yeah,
Bruce, do you want to add to that?
Yeah, so I think there's standardization of voltage, standardization of the mechanical connectors.
I think you need to speak up a bit, sorry.
Hello? Can you hear me?
Yeah, that's good.
Okay. The standardization of the voltage, standardization of the mechanical connectors, and standardization of the communications. And I think we will see each of those proceed in that order. And of course, my focus is more on the communications angle, where things really do have to be standard for them to work. So I think we'll see a healthy diversity in the coming years.
Okay, and maybe I'll direct that question in a bit of a twisted way to you, Sharia. We had one of the, or actually there wasn't just one participant from the virtual audience, but several who were asking, you showed that big list of appliances that people want to run now after having gone through that solar home system experience, and you have this long list. Are we seeing those really ready for DC, or are they going to come out in AC first, and then you need to put an inverter? Or are we really heading towards a standardization where appliances are ready both for AC and for DC? And I think I already kind of know your answer. But what is for those appliances that right now are not able to run on DC?
Thank you very much, Anas. So this is very important. So we don't have any standard for it. I can tell you in Bangladesh, we are running the DC, isolated grid from 12 volt to 220 volts. So there are 12 volt systems in Bangladesh, 48 volt systems in Bangladesh, 125 volts, and also 220 volts. So these are all are DC grids. So we need the standard system. Right at this moment, it's true, we have the DC irrigation pumps, but for the other loads, the DC motors that are not very common in the market. So what we do, so if we have some loads like that in our DC grids, what we are considering that we'll install or we will provide a small inverter, okay, unless we have the solution, so that the consumer who wants to run a motor, run a special appliances, which is AC motors, okay, we can provide a inverter for that particular consumer.
Okay, thank you. So another question that was raised was in regard to scale up. So we've seen approaches that are now undertaken for DC nanogrids, but are we really ready to take them to scale to address the sustainable energy access for all goals? And that was also part of the discussion yesterday. Are smart grids the solutions? Now, I think I would kind of twist that. Are DC grids the solutions? And if so, are they ready to scale? Is it easy to find investors who help you push this on a large scale? I mean, we've seen Pavio with, I think, 850 customers, he said. So that's already a considerable number. But is it easy to get people to help you finance and leverage what has been done, or where are we in terms of development, in terms of scaling? Bruce, you have an answer?
I guess to me there's scaling in terms of electrical capacity, and then there's scaling in terms of the sort of physical topology of how many buildings are connected. And when you have a system with the generation distributed, then you can get very large systems where the amount of power flowing on each link isn't necessarily that large. So I guess I see very promising opportunities for scaling geographically initially.
But very practically hands-on, is it easy for you to finance your research, or is it still hard to actually get people motivated about DC who don't have that technical look at things?
For me, it's still a struggle to get interest in DC in the United States, but we're making progress.
All right, thank you. Anybody else want to add on that?
Yes, well, I don't have enough experience to directly answer your question, but looking at the costs involved, the cost for the energy service, right? Not the cost per kilowatt hour. If we look at this, then the DC grid can deliver much more cheaply than an AC grid. And so, does that mean that it's more likely to scale in terms of replication, in terms of numbers of installations? Probably. And does that mean that it's more likely to help to achieve the sustainable energy for all goals? Probably.
Okay, thank you. So I just want to ask one last question from my side, and then I think we have time to take 2 more questions from the audience. So yes, there's a potential to reach those billions out there, but yeah, I'll twist the question a bit for you. But are there also, you know, so you start electrifying households with DC grid energy services, but then are you able to grow after that? You know, are you able to, from that initial seed, from that initial energy tier electrification, are you able to grow with a single DC nanogrid? Maybe Sharia, you can answer on that.
So I can share my experience. So in Bangladesh, the DC, the AC system, the AC minigrid systems are supported by the government. You know, the ITCOL is providing 50% grant for the AC minigrids, and so far we have 4 AC minigrids. But in terms of, you know, cost of energy, this is much cheaper, and government is not supporting the DC grids so far. Okay, but we have almost 50 DC grids. I mean, the individual, you know, entrepreneur, they have introduced the systems and they are making profit out of it, and this is sustainable. Okay, that's why I'm very much optimistic on DC systems, without subsidy and without any grant support. So they have developed their business model, and DC appliances are much more efficient. You know, that's why people are getting almost the same service, same energy service with much lower cost. That's why the DC systems, they are going in Bangladesh. I mean, DC nano-grids or DC isolated grids, they're going in Bangladesh without any subsidy or without any support. Thank you.
So we're open for 2 last questions, and I see them from the left and the right. Sorry, they were faster in the back. So no, I'm actually using this microphone. So, help me there.
Thanks. So, like you, I'm a fan of DC mini-grids, but when we ask about can they scale, it seems that over the last 3 years, most of the DC mini-grid people have moved over to either AC mini-grids if they're dependent on grant funding, because those systems aren't being built to minimum cost, they're being built to meet the demands of funders, in particular the Rockefeller project. Right? Or we're seeing those people move across to solar home systems because of the reduction in complexity, especially dealing with regulation and stuff like that. So I'd love to see DC mini-grids scale, but how do we break that nexus? I mean, you know, Fabio's project talks about 850 users, and that's one of the bigger DC mini-grid projects out there. A small solar home system program, like minimum order quantity on solar home systems is 500 units. So there's many, many solar home systems projects that are in the thousands, tens of thousands. So how do we cause that shift back to what I think most people here would agree is probably the best, most economical solution of DC mini-grids?
All right, somebody want to take that? I think Sharia, Timothy, you're taking it.
Okay. Well, just, you know, what Sharia mentioned a moment ago, the fact that the AC mini-grids are subsidized by the government in Bangladesh to 50% of the cost, whereas the DC mini-grids are not. I think that's something that needs to be addressed. I don't know. I mean, I don't have an answer. Sorry.
We have 2 answers popping up here. Asma?
Not an answer, just mention that the DC mini-grids that are there in Bangladesh, the cost is divided into the users. The user has to pay so much. All the users together will pay for the price for the investment. So it is either the government for the mini-grids, government is paying the subsidy, and because the systems are smaller, less amount is necessary, so it is affordable for the users to invest. But for AC mini-grids, which they'll have to be more than 150 kilowatt, so that would need more money. So that's why you can't compare it like that. And the other thing that I wanted to know is AC has been in use for a long time. There are people who install, who repair, who are trained in using and maintaining these equipment. So until a lot of DC equipment appliances are available, I don't think it is a good idea to scale up before being ready for it.
Yeah, thank you very much for that comment. Timothy, you want to add to that?
Respond to that. Look, I think that we ought to be trying to create level playing fields for different types of technologies, whether it's the national grid, whether it's an AC mini grid, solar home system, or a DC nano-grid. And to say, well, yes, the DC nano-grid is cheaper, therefore we don't need to subsidize it. You know, I don't think that's the right way to look at it.
Okay. Yeah.
You know, it's a chicken and egg kind of problem. You know, if you don't build the DC mini grids, then the loads and so forth won't become available. And if you use that as the reason not to do it, then you'll never get there.
Okay, we had one last question.
In case of DC grids, like yesterday I had asked a question from the professor. There are only protection devices for the system, the entire system, but there are no protection devices for individual households. For example, in AC, if you have an AC grid, okay, and for human protection, there's there is a 100 mA RCD, or sorry, for device protection there's a 100 mA RCD, and for human protection there's a 30 mA RCD. Now, these are not there in DC, so. Like, is there any example that's there in Bangladesh, or is there anybody manufacturing it, or is there any standards, or are we fixated on any standards on how to protect people in case of there are any problem there?
There are. Okay, and in case of standardization, you know, we have a lot of discussion yesterday. So we are you know, in lack of standard things for the DC grids or the DC systems. So we need that. But say, for example, I would like to comment on Asma that we have noticed that for the AC grids, so though we are having 50% of grant from the government, but we cannot make the AC grid financially viable unless we go to the size of 100 kilowatt. Okay, but there are some rural areas. You will find many rural areas. So in the rural villages, you will not get 100 kilowatt load. So maybe there are some clusters of 10 households or 20 households. So how can you provide them electricity with a 100 kilowatt, installing a 100 kilowatt AC systems? That will never be cost effective. So we are searching for, you know, in Bangladesh, ITCOL has a plan for 50 mini grids by next year. Okay, but we are facing now difficulties. We are getting off-grid areas, but those off-grid areas are not feasible for installing AC mini grids, because AC mini grids we cannot, you know, install less than 100 kilowatt. So how will we provide energy to them? So either we go for solar home systems, or we can install DC grids like 10 kilowatt or 20 kilowatt.
Okay, thank you very much. I know there were much more questions, and I hope we can take that discussion now both online for everybody who's joining us online to the follow-up, which will happen through Energypedia, but also directly by email. And then
could I have one
physically now in the tea break? Yeah, Bruce.
Yeah, one point on this question of how to make DC more successful. Certainly in places like the United States, we're going to have very few buildings that are entirely DC anytime soon. So any building is going to be a mixture of AC and DC systems, so we need to have inexpensive ways to interface between a DC grid and an AC grid within a single building. So I would think that in places in your part of the world where there are AC grids, if we could have inexpensive devices so that people could have DC appliances interface through a converter to their AC systems, we could reduce the need to have it be a all one or all the other choice, and that might be a helpful way to drive up the demand for DC appliances. Essentially, a small DC grids inside of the AC provided houses.
All right. I think that's an interesting insight to close with. Again, thank you all for joining us, and Bruce also for staying up so late at night. Yeah, it was a pleasure to welcome you all here, and yeah, I'm looking forward to continuing this discussion also after this session. Thank you so much.